To solve a system with Gaussian elimination, we need to get this in triangular form, meaning we need to get rid of everything that is below this line here, okay? And get rid of these entries here. And I like to move from left to right and from top to bottom as I get zeros. So I'd like to get a 0 in this spot right here. To do that, we can use the various operations that we know will yield equivalent systems. So this x right here I can get with by subtracting the x above it. So we're going to take equation 2 and we're going to add -1 times equation 1. Okay, we know we can add a non-zero multiple of an equation to another equation, and this will be our new equation 2. Now I like to just write this as minus equation 1. I think it just is a little bit more intuitive as far as what's happening. But remember that that is equivalent to saying that we're adding -1 times equation 1. So this gives us a new system. This will give us, our first equation stays the same, of course. Oops, that's a z. And then here we have x minus x, and that just disappears. There's just a 0 there. And then 2y minus -2y is 4y. And then -z minus 3z is -4z. And 13 minus 1 is 12. Okay. And then we have our 3x plus 2y minus 5z equals 3. Okay. So that's the system that this operation gives us. But now we can go and do this essentially again, but we can get rid of the 3x. And what we're going to do is we're going to take this third equation and subtract 3 of the first equation. So equation 3 and subtract 3 times equation 1. Or you could write this as equation 3 plus -3 times equation 1. And that will be our new equation 3. Okay. So equation 1 stays the same. And equation 2 stays. And for equation 3, we have 3x minus 3x is 0. And then 2y minus 3 times -2y is plus 6y. So 2y plus 6y is 8y. And then -5z minus 3 times 3z is minus a 9z. So -5z minus 9z is minus 14z. And then 3 minus 3 times 1 is 0. So notice that we've now gotten rid of the spots right here. To get this into triangular form, now we just need to get rid of this 8y right here. It's really easy to get rid of this 8y by subtracting 2 of this 4y. So we're going to take equation 3 and subtract 2 times equation 2, and that will be our new equation 3. So our new system of equations, our first equation and our second equation stay the same. And for our third equation, we have 8y minus 2 times 4y, so that's just 0. And then -14z minus 2 times a -4z, so that's plus 8z. So -14z plus 8z is -6z. And then we have 0 minus 2 times 12, so -24. And so this is now what we call triangular form. Triangular form. And to solve this system now is super easy. We just use back substitution. So this third equation, we just can divide by -6, and we get z equals 4. Okay. Then we can take that and plug it into the second equation. So we have 4y minus 4 times 4 equals 12. So 4y equals, let's add 16, and we get 28. So y is equal to 7. And now that we have z and y, we can plug those into the first equation. So x minus 2 times y, which is 7, plus 3 times z, which is 4, is equal to 1. And that's x minus 14 plus 12 equals 1, or x minus 2 equals 1. So add 2 to both sides, you get x equals 3. So there's our solution. Okay, x equals 3, y equals 7, and z equals 4. Or we could write this as an ordered triple, x, y, and z.